Hey guys, in this video we are going to look at how you would go about interpreting chemical formulae. So chemical substances are most usefully represented in their chemical formulae forms. So on this page that you see in this video, I have written out 5 different chemical formulae. Now, formulae is plural for formula. Plural for formula. Sometimes you see people writing chemical formulas. I think formulae is correct in Australian Standard English. But okay, let's go. So let's have a look at how we can go about interpreting them. So when we look at chemical formulae, we find that elements are represented in their symbols, with their elemental symbols. So potassium here, for example, potassium, if you look at it on the periodic table, is represented with a K when you represent it with its elemental symbol. Oxygen here is represented with an O. So chemical formulae represents all the elements with their symbols. Okay. The next thing you might notice is that you would find these numbers that are subscripted to the right of certain element symbols. Now, the numbers that follow to the right of any element tell you how many of that element there are in the compound that you've written out, or the substance that we're dealing with. So in this case, K2O is potassium oxide. And with potassium oxide, if you're going to represent it correctly, it looks like this, K2O. Now, K2O just tells us that there are 2 times potassium ions and 1 time oxide ions in the compound. Simple as that. You might ask, why doesn't the oxygen have a 1 in front of it to tell you that there's 1 oxygen? Well, the rule is that if there is only one atom of an element, in this case oxygen, there's only 1 atom of oxygen, we don't need to write anything. We don't need to write anything for that element. We just take it for granted that there's only 1 oxygen atom. Right, so if we go on to the next example, Co2 carbon dioxide, you can pause this video to work out how many atoms there are in each. You'll find that there is 1 times carbon atoms and 2 times oxygen atoms. This subscript here only applies to the oxygen and not to the carbon. So remember, the subscript follows directly after every element. And it only tells you how many of the element that it follows directly after. Okay. If we go to the next example here with Fe2O3, iron 3 oxide, we see that in terms of ions, there are two of them, and there are 3 oxide ions in the formula. All right, so now we're getting to compounds with more than 1 element. KNO3, potassium nitrate, is an interesting one. It's interesting because the nitrate, the NO3, so I'm just going to draw a grey, no, actually I'll just do a dotted box around it. This here is considered a polyatomic ion, more specifically a polyatomic anion. NO3 minus is an anion on its own. But you note how you don't draw brackets around polyatomic ions. as you would if there are more than one of that polyatomic ion, as you would see with iron 2 nitrate. So if you look over here, we have that same ion, but now it's bracketed. But what is the difference between potassium nitrate and this iron 2 nitrate compound here? What is the difference between them? Well, the difference is that we have this subscript here after the bracket. What might this mean for the nitrate ion? Well, this means that there are 2 times nitrate ions. It's worth noting that the only time we ever put a bracket around nitrate ions, put brackets around any part of a chemical substance, I should say, is when we're dealing with polyatomic ions, and there are multiples of those polyatomic ions. So there must always be like this subscripted number that follows the brackets. Now, if you want to read further about when brackets are used, I would go to this link here. Now, I'll put this link in the description for this video, so feel free to go there. But if we just go back to this KNO3 potassium nitrate example, it's pretty easy to work out how many of each element there are. There's 1 potassium because there's no subscript in front of it, so I'll just asterisk this. There's no subscript there, no subscript in front of nitrogen either, which tells us there's only 1 nitrogen. And there's 3 oxygens, 3 oxygen atoms. Okay. All right, now with iron 2 nitrate, how many ions are there? There's no subscript in front of iron, so there's just 1 ion, 1 ion atom. But okay, now it gets a little bit tricky with these brackets. So how these brackets work is that the number that is subscripted directly to the right of the brackets tells us how many of the ion there are. So the way that you would use it is to multiply this number with the subscripts that follow any of the atoms inside the bracket. Now, nitrogen doesn't have a subscript, but it's implied that there is a subscript of 1. Note that I say implied. Now, if you ever have to write a subscript of 1, you should remove it. There's no place for that subscript. But nitrogen here, there's 1 in the nitrate ion, but there's 2 nitrate ions, so you could say there are 2 nitrogens. Now there's 3 oxygens in a nitrate ion, but because we have 2 nitrate ions, we could say that there are 6 oxygens. Okay. So we've unpacked a bunch of chemical formulae. It's really important that you meet the learning objectives for this video. So you should be able to identify what the subscripts that follow element symbols mean. Note how I say they always follow element symbols. That is, they are to the right of element symbols. Now, it's important that you are able to also explain what no subscript in front of an element symbol means for the number of that element. If you don't see a subscript, it means there is 1 of that atom. Finally, you need to be able to describe when brackets are used and how they are interpreted. So we only use brackets when there are polyatomic ions involved. And the way that we interpret them is that, the subscript that follows these brackets tells us how many of that polyatomic ion is in the chemical formula. All right, guys, thanks for watching.